Hello students, welcome to the course Digital Electronics and Computer Organization presented by Department of Information Technology, Sanjeevani College of Engineering, Kopargaon. In this video, you will learn topic 1.7 demultiplexer or decoder from Unit 1 Combinational Logic Circuit. This is the outline of the topic. In the beginning, we shall see 3:8 decoder, then 2:4 decoder with enable input, and then we shall construct 4:16 decoder using 3:8 decoder, and finally we shall use decoder for the purpose of implementing the Boolean functions. First of all, what is a decoder or demultiplexer? Demultiplexers, demux, are combination logic circuits which has single data input and multiple output. It also has select or control inputs which selects one of the input, one of the data output and transfers logic level or the data on the data input to the data output selected. The logic symbol of demultiplexer is shown in this particular diagram. So it is exactly reverse function. Its function is exactly reverse of that of the multiplexer. Only one input and several outputs, data outputs. So the select lines are used to select one of the several outputs, and the data which is there on the data input will be transferred to the selected output. Decoder is the same circuit as that of the demultiplexer. So many times decoder and demultiplexers, they are used in place of the other, okay, or exactly they have the same circuits. Only the thing is that the data input is used as the enable input, okay. So the demultiplexer can be represented as the decoder in this particular fashion. uh, the select lines are now used as the input lines, okay, so those are the select lines, and the data input is used as the enable input, and the outputs of that particular decoder as shown here. So this becomes a demultiplexer, it becomes a decoder. So this is how the decoder and demultiplexer functions, they are interchangeable. Demultiplexer can be used as the decoder. So here in this table we shall demonstrate that how the decoder and demultiplexers, they are similar. Like multiplexer, we can have demultiplexers with different number of select or control input and outputs. The relationship between the number of select or control inputs and the number of data outputs of demultiplexer or decoder is fixed, and it is n is to 2 to the power n, where n is the integer. If a demux or decoder has n number of select or control inputs, there will be 2 raised to power n number of data inputs for the demultiplexer. So in this table, the first column n takes the values 1, 2, 3, 4. With value of n1, the demultiplexer is 1 is to 2 demultiplexer, or it is also called, or it can also be used as 1 is to 2 decoder. So it will have two data outputs, one select input and one data input, but in case of decoder it will be enable input. The 1 is to 4 demarks will, when n is equal to 2, it will be 1 is to 4 demarks, or it will be 2 is to 4 decoder, which will have 4 data outputs and 2 select inputs, whereas there will be only one data input, or for decoder it will be enable input. When n is equal to 3, it will be 1 is to 8 demarks, or 3 is to 8 decoder, which will have 8 data outputs and 3 select or control inputs, whereas 1 data input. The fourth one, when n is equal to 4, it will be 1 is to 16 demarks, or it will be 4 is to 16 decoder. So this device will have 16 data outputs and 4 select or control inputs, and 1 data input, or which will be acting as the enable input if it is used as decoder. So this is how you can use the decoder.